Find part A, the equivalent resistance of the circuit in figure. Part B, each current in the circuit. Part C, the potential difference across each resistor. And part D, the power dissipated by each resistor. Draw the figure. Consider the points. This is the point A and another one is the point B. Between the points A, B, connected to the one battery. This is the battery 15 volts. And connected to the another point C. This is the point C. Between the AC connected to one resistance 6 ohms. The current through the resistance AC is the I1. And connected to another point D. This is the point D. Between the CD connected to one resistance is the 6 ohms. This is the 6 ohms and the current through the AC is the I2. Between the points BD, the resistance is the 6 ohms. And consider another point E. This is the point E. Between the CE connected to one resistance is the 2.4 ohms. And the connected to the CE is the current through the CE is I3. And consider the ED. Between the ED connected to one resistance is the 6 ohms. And the current through the ED is the I4. This is the I4. And consider the point F. This is the point F. Between the FD connected to one resistance. This is the 9 ohm resistance. And connected to EF, one single line. This is the given circuit. And the current through the EFD is the I5. This is the I5. This is the given circuit. First of all, we can calculate the equivalent resistance in the circuit. So, this is the part A. The resistance between the ED 6 ohms and another 9 ohms, both are connected into the parallel to each other. So, the equivalent resistance in the parallel circuit is the RED. So, the reciprocal of the equivalent resistance in the parallel circuit is equal to the reciprocal of the sum of the individual resistance. So, 1 by RED is equal to sum of the reciprocal of the individual resistance. So, 1 by 6 ohms plus 1 by 9 ohms. RED is equal to 3.6 ohms. This is the equivalent resistance in the parallel circuit between the points ED. So, draw the another figure or modified figure. This is the battery 15 volts and this is the 6 ohm resistance between the points AC. The current through the AC is the I1 and this is the point B. Between the points BD, the resistance is the 6 ohms and the resistance between the CD is the 6 ohms and the current through the CD is the I2. And consider the another point E. This is the E. The resistance is the 2.4 ohms and the current through the CE is the I3. And the equivalent resistance, this is the RED connected to between the points ED. So, this is the ED. The resistance is the 3.6 ohms. So, the current through the ED is the I3 because the resistance 2.4 ohms and 3.6 ohms both are connected into the series. In the series circuit, at any resistance the current is the same. So, I3. The resistance between the CED is the 2.4 ohms and 3.6 ohms both are connected into the series. So the equivalent resistance is the RCED is equal to sum of the individual resistance. So 2.4 ohms plus 3.6 ohms. So RCED is equal to 6 ohms. This is the equivalent resistance in the circuit between the points CED. So draw the another modified figure. This is the figure 1, this is the figure 2, and draw the third figure. This is the voltage 15 volts between the points A connected to 6 ohm resistance. This is the I1, and this is the point C and connected to 6 ohm resistance. This is the 6 ohm resistance. This is the point D. Between the CD, the resistance is the 6 ohms. This is the 6 ohms, and this is the current is the I2, and connected to the RCED, the resistance is the RCED is the 6 ohms. So this is the 6 ohms. The current through the RCED is the I3. Consider the resistance 6 ohms and another 6 ohms, both are connected into the parallel to each other. So the equivalent resistance in the parallel circuit is the RCD. So the reciprocal of the RCD is equal to sum of the reciprocal of the individual resistance. So 1 by 6 ohms plus 1 by 6 ohms. So RCD is equal to 3 ohms. So the equivalent resistance in the parallel circuit is the 3 ohms. So draw the another figure. This is the 15 volts battery. This is the point A connected to 6 ohm resistance. This is the point C, and connected to the resistance is the equivalent resistance is the RCD is the 3 ohms. This is the 3 ohm resistance, and connected to 6 ohm. This is the point B, this is the point D. So the current through the resistance is the AC is the I1. First of all, we can calculate the equivalent resistance in circuit. 6 ohms and 3 ohms and another 3 ohms, both are connected into the series. So the equivalent resistance in the series circuit is the R equal. R equal is equal to sum of the individual resistance. So 6 ohms plus 3 ohms plus 6 ohms. R equal is equal to 15 ohms. This is the equivalent resistance in the circuit. This is the part A. And consider the part B, the current in the loop. So this is the part B, the current in the loop. First of all, we can calculate the current in the circuit. I is equal to V by R equal. The current in the circuit I is equal to V by R equal. The current I is equal to, the value of the V is the 15 volts by R equal is equal to 15 ohms. So I is equal to 1 ampere. This is the current in the circuit. First of all, consider the figure 4. In the figure 4, the resistance 6 ohms, the resistance 3 ohms and 6 ohms resistance, both are connected into the series. In the series circuit, at any resistance the current is the same. So the current through the 6 ohms resistance is the I1. This is the AC. Consider the AC point. The current through the I1 is equal to I, because the value of the I1 is equal to 1 ampere, because in the series circuit the current in the at any resistance is the same. So I1 is equal to 6 amperes. And consider the current between the CD. First of all, the potential difference between the CD is VCD. VCD is equal to the current through the circuit into at that resistance. So the current through the CD is the I and the resistance is the RCD. So VCD is equal to the current in the circuit 1 ampere into RCD is the 3 ohm resistance. So VCD is equal to 3 into 1 3 volts. This is the potential difference between the points CD. And consider the figure 3. From the figure 3, the resistance 6 ohms and another 6 ohms both are connected into the parallel between the point CD. So in the parallel circuit, at any resistance the potential difference is the same. So at the potential difference 6 ohm resistance is the VCD, and at the potential difference another 6 ohm resistance is the VCD. So the current through the 6 ohm resistance I2 is equal to the current through the CD. The current through the CD is I2. I2 is equal to the potential difference between the CD, the potential difference between CDs, that is the VCD whole by the potential difference at the CD by the potential difference at the CD by the resistance at the CD. So I2 is equal to VCD by RCD, that is equal to the value of the VCD. VCD is the 3 volts by RCD is the 6 ohms. So I2 is equal to 3 by 6, that is equal to 0.5 amperes. This is the current through the 6 ohm resistance between the points CD. And find the current through the I3. So the current through the I3 between the points CE. This is the point CE. This is the I3. I3 is equal to the current, the potential difference between the 6 ohm resistance. So this is the VCD whole by the resistance is the RCD. I3 is equal to the value of the VCD. The value of the VCD is the 3 volts whole by the resistance is the 6 ohms. So I3 is equal to 3 by 6 is equal to 0.5 amperes. This is the current through the CE between the points 2.4 ohms. So the current through the 6 ohm resistance between the points EA. First of all, we can calculate the potential difference between the ED. So the potential difference between the ED. Consider the points ED. The potential difference between the ED is from the figure 2. From the figure 2, the current through the ED is I3 because 2.4 ohms and 3.6 ohms both are connected into the series. In the series circuit, at any resistance the current is the same. So the current through the ED is the I3. So the potential difference between the ED is VED is equal to the current through the circuit into the current through the circuit I3 into the resistance. So RED. So that is equal to the current through the resistance. The current through the resistance is the I3. I3 is the 0.5 amperes into the resistance is the 3.6 ohms. So VED is equal to 1.8 volts. This is the potential difference between the points ED. So consider the figure 1. From the figure 1, the resistance 6 ohms and another 9 ohms both are connected into the parallel between the points ED. In the parallel circuit, at any resistance the potential difference is the same. So the potential difference on the 6 ohms and 9 ohms both are the same, that is the VED is equal to 1.8 volts. So the current through the ED is the current through the ED is I4. I4 is equal to the potential difference in the ED. The potential difference in the ED is the VED whole by the resistance between the points ED. So RED. So I4 is equal to 1.8 V whole by RED is the 6 ohms. So I4 is equal to, value of the I4 is equal to 0.3 amperes. This is the current through the 6 ohm resistance between the points ED. And consider the current through the 9 ohm resistance between the points FD. Between the points FD, the current through the 9 ohm resistance is the I5. I5 is equal to the potential difference between the points FD is the VD. The potential difference between the FD is the ED, because 6 ohms and 9 ohms both are connected into the parallel. In the parallel circuit, the potential difference is the same. So VED by the resistance in the circuit RFD. So I5 is equal to 1.8 volts whole by the resistance is the 9 ohms. So I5 is equal to 0.2 amperes. This is the current through the 9 ohm resistance between the points FD. And consider the part C. The potential difference at resistance is the potential difference at a resistance is the V is equal to I into R. So first of all, we can calculate the potential difference between the AC. Potential difference between the AC. AC is equal to VAC. VAC is equal to I1 into RAC. So VAC is equal to, the value of the I1 is the 1 ampere into RAC is the 6 ohms. So VAC is equal to 6 volts. This is the potential difference between the points AC is the VAC 6 ohms. And the potential difference between the points CD is the VCD. VCD is equal to I2 into RCD. So VCD is equal to, the value of the I2 is equal to 0.5A into RCD is equal to 6 ohms. So VCD is equal to 3 volts. This is the potential difference between the points CD is the 3 ohms. And the potential difference between the CE is the potential difference between the CE. This is the CE is the VCE is equal to I3 into RCE. So VCE is equal to, the value of the I3 is equal to 0.5 amperes into RCE is equal to 2.4 ohms. So VCE is equal to 1.2 volts. This is the potential difference between the points CE. And the potential difference between the points ED is equal to, this is the ED. VED is equal to I4 into RED. So VED is equal to, the value of the I4 is equal to 0.3 amperes into 6 ohms. So VED is equal to 1.8 volts. This is the potential difference between the ED. And the potential difference between the FD is FD is the VFD. VFD is equal to I5 into RFD. So VFD is equal to the value of the I5 0.2 ampere into 9 ohms. So VFD is equal to 1.8 volts. This is the potential difference between the points FD, and the potential difference between the points dB is the potential difference between the points dB is VdB. VdB is equal to current through the resistance is the I1, because the resistance is connected into the series to the battery, so I1 into RdB. So VdB is equal to the value of the I1 is the 1 ampere and RdB is the 6 ohms. So VdB is equal to 6 volts. This is the potential difference between the points. dB is 6 volts. And consider the part D. Consider the part D. The power dissipated in any resistance is P is equal to V square by R. The power dissipated in the point AC is PAC is equal to VAC whole square by RAC. So PAC is equal to VAC is the 6 volts whole square by RAC is the 6 ohms. So PAC is equal to 6 watts. This is the power dissipated in the AC is the 6 watts. And the power dissipated in the CD. The power dissipated in the CD. CD is the PCD. PCD is equal to VCD whole square by RCD. So PCD is equal to VCD is the 3 volts whole square by RCD is the 6 ohms. So PCD is equal to 1.5 watts. This is the power dissipated in the 6 ohm resistance between the points CD. And the power dissipated in the CE is CE. CE is the PCE is equal to VCE whole square by RCE. So PCE is equal to the value of the VCE is equal to 1.2 volts whole square by RCE is the 2.4 ohms. So PCE is equal to 0.6 watts. This is the power dissipated in the 2.4 ohms resistance between the points. CE is the 0.6 watts. And the power dissipated in the ED. ED is PED is equal to VED whole square by RED. So VED is equal to the value of the VED is equal to 1.8 volts whole square by RED is the 6 ohms. So PED is equal to the value of the PED is equal to 0.54 watts. This is the power dissipated in the 6 ohm resistance between the points ED. And the power dissipated in the FD is the PFD. PFD is equal to VFD whole square by RFD. So VFD is equal to 1.8 volts whole square by 9 ohms resistance. So PFD is equal to 0.36 watts. This is the power dissipated in the circuit. 9 ohm resistance between the points FD, and the power dissipated in between the points dB is dB is the PdB is equal to VdB whole square by R dB. So PdB is equal to the value of the VdB is the 6 volts whole square by R dB is the 6 ohms. So PdB is equal to 6 watts. This is the power dissipated in the 6 ohm resistance between the points dB.